So once you open your Eagle software, the first window you will see will be Eagle control panel. So first thing we're gonna do is you have something called libraries. So these are the default libraries which comes from Eagle. What we're gonna do is we're gonna add Fab libraries here. So if you just go ahead and Google, say, so what I just Googled was Eagle Fab library, and I got the second link which I opened here, and these are the library you want to download. So the extension for the file is .lbr. You can just, so you have to right click and save target as. So then this is I don't know, it should be .lbr. Make it .lbr in downloads. Same with other files. .lbr. And this is Neil's personal library file, which he's not updating anymore, but it's useful to have it. Okay, so once you download it, you have to add it, and for that you go to options. So everybody has downloaded the library files? Yes?
Process.
Okay, in process. So once you download it, you go to options, directories, and the directories you have libraries folder. Just browse to the location where you have your library downloaded. Select folder. Actually, I should organize it properly. So I'm going to go to my downloads folder and Control X, new folder. Yeah, you want to, so it's taking it as a, I'm going to download it again because it downloaded as a HTML file. Desktop, Eagle library, file. .lbr. Save. .lbr. Save. Okay, once you have done that, you can again go back to your options, directories, and in library you can select that folder. So in my case it's in desktop, Eagle library. Okay.
So you lose the access for the previous libraries?
Pardon?
You lose the access for
No. So you will have one more folder. So initially when you opened it, there was only one folder called LBR. Now you have two folders, the one I added right now. So everyone with me?
Yeah.
Yes. Okay. So once you are doing it, now you can see there is like a dot there. If it's gray, then it means that it's not under use. So you right click and select use all. So once you do that, then this dot will become green. So now you are using the library. Okay, so now we have the library for all the components we have in the Fablab. So basically we can just go to this library and use the component and make sure that we have it in our inventory. So to create a project, you can just go in project folder. I usually do file, new, project. You're gonna name it. So I'll say just hello. Sorry. I'm gonna rename it. Say hello micro. So it's for microcontroller programming. Now inside it, first you will create a schematic, and after the schematic, then you can create a board according to it. So just right click and then create schematic. I usually like to save it before editing anything. So I'll save it as hello micro. Okay, so the next thing you want to go do is go to view, grid, and turn on. So by default the grid is turned off. I usually like it to keep it on. So now that will open a grid. So let's try to make a similar board. So here we are using 80tiny45. So I'm just gonna go and use command add add, hit enter. So that will open up a window which is all the libraries here. Now I'm gonna scroll to Fablab library. So one of them is Fab, and I can see there's 80tiny44. I'll see if there's a better version of that. 80tiny EVRISP. Okay, so let's just select 80tiny44, which is this one. Click OK. So here you have 80tiny44. Now once I click it, one of the thing is pasted, but still there. For this is useful if you have like multiple resistors, so you can just keep on clicking it. But I don't want it, so I'll just press the escape button and then cancel it. So here you can see there's like 8 pins, which is corresponding to the 8 pins of your microcontroller. One of the pin is reset pin. Then there's again all this you can just read in the data sheet. So if you Google 80tiny45 data sheet, you will see all the information to it. I'm quickly gonna connect an ISP connector, a reset pin, and try to make a board very quickly. Okay, so first thing I'll do is I will connect the ground and VCC. So that will be add, and let's connect say this. So this is my connector, which is the power connector, two of the power connector. Now what you're gonna do is you're gonna first make a net, which is basically wires. So to connect two things, for example, if I add a resistor, I go add, and then I use a resistor. Let's see if you can find a resistor. Switch at mega EVRISP, LED, RGB LED, MOSFET, pin, resonator, regulator, solder, USB, resistor. Okay, so we have a resistor here. Now resistor comes in a different packaging. The one we are using is 1206. So just click on that. Again, you can see that 0402 is the smaller version of it. That probably we can't mail it with our machine, so we're gonna stick to 1206. Just click on that. Now I know the circuit diagram because I have done it multiple times, but you will read the data sheet, and in the data sheet and in application note you will find the circuit diagram. So I know that this resistor connects to the reset pin, which is this one, and then it goes to 5 volt. So I'm going to add another VCC. We'll just do add. You can also search it, but I usually don't like the searching because it doesn't work quite well. So this is VCC, which is my 5 volt. So now what I want is I want to connect this pin number 1, which is the reset pin, through a resistor to 5 volt. So I have first kept all the thing which I want, added all the thing I want, and just going to connect it. So to connect it, the command is net, net net. So just go net, hit enter, click this. So this is connected. The other side, this is connected. Now this is only the schematic. There's a board which you have to design. So first you have to create the board. To create the board, you have to click on this button which says generate switch to board. So because I'm clicking it for the first time, it will first ask me to create the board from the schematic. So I just say yes, and this is my board. Here also I like to change the grid. So I'm gonna switch to mil is my thing, make it 20 mil grid and turn on the grid. Okay, so now you have your thing. You can just move your microcontroller based on where you want it. Then you can connect your resistor like this. So let's populate a little bit more, and then we can make a little circuit. So once that is done, other thing you want to add is put a ground in it. So I'm just going to go and do add, and then search for GND. GND is for ground. Let's search for GND. Again, I got the ground. You can click it here, put it here, and now to connect it, what's the command I should use? Net. Okay, so just do net and then connect it here. So this is my, so Now I want this pin to actually connect here. So one way I can do is I can just add VCC and ground here and then connect it. So what I'm going to do is just add one. So I'm going to add one ground and then I'm going to add one VCC. So just add one more VCC. Let's search for VCC, and here's VCC. I can add it and then use the net command to connect it to pin this and this. So if I go back to my board, I can see that this connector has VCC and ground in it. So I can use the move command, which is this move button, and bring it over here. This I can orient it in the way I want. So typically what you need is in a bare bone PC microcontroller circuit, you need a reset pin which is connected to VCC. Then you need 3 pin, which is your programming pin, which is your ISP connector. So I'm going to add ISP connector, which is add. Then navigate to my fab inventory, fab library, and I have AVR ISP connector, this SMD one. I'll just let's do it again. Fab hello, AVR ISP SMD, click OK. So here again you have to do all read the data sheet to find out like what pin means what. I can quickly tell you what it means. So reset pin connects to the reset pin of microcontroller. Then you have MISO, MOSI and SCK pin, which is basically pin corresponding to your microcontroller. So if you look carefully, so pin number 6 is a MISO pin, it's labeled here. Okay, pin number 5 is MOSI pin, which is labeled here. So all I need to do is connect MISO pin over here, connect MOSI pin over here, and then SCK pin, which is pin number 6. Okay, so one way to do it is just do net, and MISO pin will directly connect over here, and the MOSI pin will connect from here to here. Sorry, yeah, that's VCC. So to delete it, you can just use command delete, DELETE, delete. Then do net again. Okay, so now reset here is all the way here. So what I can do, one technique is I can label my pin. So which will be first create a half net. So just do this, double click, do double. So you are not ending it, it's an open-ended wire right now. And then you're going to just label it. So I'll do label. So once you click it, it's going to do a by default name, but I'll change it to what I want. So then the next command to change that is name. Just click name. This will be your RST, and this will be your SCK. Now if I do the same thing here, if I label this thing RST, technically this and this two thing will be connected. So I'm going to do again label and then name it. So I'm going to name it as RST. So when I say RST, it actually asks me whether I want to connect this to this, and that's what I want to do. So I'll just connect it. Same with SCK. So I'm just going to do net, create an open-ended wire, label it as default, and then rename it to SCK. Name it as SCK. Again, it's going to ask me whether I want to connect this pin to this. Yes, I want to. So that's yes. If I go back to my board, I can see that there is connector here. Okay. Now this really gets very tricky when you have a lot of circuitry because you have to manually route it. So right now the yellow wire just tells you that these wire will go to a particular location. Okay, so to route it, basically you just route the route command, or you can use this circuit. click here, then you can see that this is highlighted red and this is highlighted red. What it tells you is these two are going to be connected. So you click here and then you click here. So one is connected. If you want to connect this, then it tells me that this connects here or here. So I can go from here all the way here and here. Similarly, this will go like this. Now, once you have more and more components, it gets a little tricky to do all the routing. So most of your time in the development will go on doing the routing part of it. It does have a it does have an option for auto routing, but that's useful only if you are giving for fabrication, because sometimes what it does is it's going to actually do double layer, and you can't do double layer here. So I think I never used it. Yeah, so if you do auto routing and collect, continue and start. Okay, so it does did it. So if you do auto routing, this is what it did. Now fortunately it did a single layer, so this is possible. So you can simply take this and then mill it. But if it does two layer, then you can't do it. Usually I use auto routing as a tool to first get a little idea, and then I do manually. I can cancel it. And whenever you are making board, you have to make sure that you keep it close together. Okay, so with this, once you, for example, route it, so let's just make it route first. Continue, evaluate. Okay, so now it's routed. Now assume you want to convert this as a PNG file that will go inside your machine. So first I'm gonna shrink it to the size I want. So I'm just gonna go move and just bring it close. Okay, now the second thing is I'm going to create a rectangle which will act as a boundary for my circuit. So click on rectangle and select your layer as bottom, and then create a rectangle. So to export it, there's a trick is first you only want the track, and then you only want the rectangle. So in Eagle you can do that by just selecting layers. So you just select the top layer, which will be just this, and then all you need to do is file, export, image, full. You can name it like micro, and save it. You have to save it as monochrome. Resolution is 1000 dpi. Click OK. So if I do that and if I go to Eagle folder, it will be documents, Eagle, hello micro, you can see Eagle. Okay. So this is your track which will go in the machine, and then you can create a board. The other thing you want to do is create a boundary. So for boundary, you can go to layers. Now this time instead of selecting top, you can select bottom. We'll just do the bottom. And again file, export, image. I can just add as it as a boundary, so say BG, save, do monochrome and click OK. So if I go back to my folder, I'll see another PNG image which is just the boundary. So again, to summarize the entire workflow, what you will do is you will first think about what you want to do. Like, do you want microcontroller that will blink LED? Do you want microcontroller with motor or LCD or whatever application you have? Now once you have that, you're going to make a circuit diagram. So that will be in your piece of paper. So you'll draw your microcontroller, you'll draw your motor, and you'll draw your all other ICs, and then see how it's going to connect. Now once you have your circuit diagram ready, then you're going to go to Eagle and make your schematic. Okay. Once you have your schematic ready, then you can go back. So making a schematic and board is almost a parallel process, where you make schematic and then you add few component and then you route it. Now once you have routed it, then you can export it as a PNG file. Those PNG file will be used to mill the board. Then you know which component is what, so you can stuff it. Once you stuff it, then again you can use HTML Studio, or there are many other options to program your board. So that sort of completes your design to implementation. So you design an idea and then you make it a reality. Okay, perfect. Any questions? So for starting, what you can do is like Neil has covered almost many sample boards. So for example, this is a light sensor. Let's see if we can download the video. Open. Just use the recommended settings. Okay, most likely that, yeah. So this is what Neil made, which is basically a light sensor. So if it's a shadow, then the reading changes. So this is connected to a computer, and it's sensing the light and then pushing that data into a computer. There are many other devices. This is an accelerometer, and there are many output devices. For example, this is an LCD. Let's open this in a new tab. Okay, so in this board, this is a tiny board which is connected to LCD, and then the microcontroller is pushing the character to the LCD. So you can see like hello, and you can write any text there. So for starting, you can go in this website and find out different boards you might be interested. For example, this is a servo board. So this will just drive a servo motor. So this is a tiny board which is controlling 2 servo motors. So I think all of you are familiar with the servo motor. Okay, so these are like a starting point for learning how to connect servo motor, how to connect DC motor, how to connect LCD, how to connect RGB LED, how to connect speaker and mic and all those things. So you can use this reference, and again, he has all the, so he has like traces and interiors and components and board, everything. So all you need to do is you can download the file. You can mill it, test it, all the components we have in the inventory, so you can test it. And if you want to use it in your project, then you can go through the schematic circuit diagram to see how it's connected, and then you can implement it in your project. Okay, perfect. So that kind of complete the electronics part of the Fablab. Day after tomorrow we'll do the making furniture and molding and custom. Okay. I know this is a lot. Usually, even after like one semester of classes, it takes a year to grasp all those things, because there's so many tiny things that you can't cover. But this was more of a, like giving you an introduction to the entire Fablab thing. Okay.
In Eagle, how do you do the ERC check? Can you do the ERC check in Eagle?
What is ER switch?
Like the connection is taking like probably ERC check.
Yeah, you can. Yeah, you can do ERC. I think it's ERC, and it tells you that this connection. So what happens during schematic is there's 2 options. One is sometimes you put circuits tracks that are so close that they cannot be milled. So for that you can do something called design rule check. So the design rule check will tell you if there's a problem. And for electric circuit check, you can do something ERC, which is which is going to tell you. For example, it is telling me right now that my resistor is not connected here. So probably I didn't connect it properly. So that I'm going to fix. Again, all of this will come as you go deeper and deeper into it. And to learn Eagle, basically all you need to do is just search Google Eagle tutorial. There's like tons and tons of tutorials for Eagle. You can also search YouTube for Eagle tutorials. They are like perfect videos for Eagle and how to use it. Okay, perfect.